everyone, welcome back to my YouTube channel. In this week's video, we are going to learn how to answer numerical questions from chapter 3. Altogether, we have 4 different questions and let's start with the first one. Question number 1. Determine the wavelength of a photon with energy of 7.67 times 10 to the power of negative 19 joule. Alright, so this is a rather straightforward question, so we just need to plug in the values in the equation. So energy is equivalent to the Planck constant times the speed of light divided by the wavelength. Alright, so in the question, you were asked to calculate the wavelength and the energy is given to you. So your E is equivalent to 7.67 times 10 to the power of negative 19. So this one is equivalent to the Planck constant, which is 6.6261 times 10 to the power of negative 34 joule second. And then your speed of light is equivalent to 3 times 10 to the power of 8 meter per second. Right, so this one you need to divide by the wavelength. So here you can find your wavelength is actually, we just have to swap the values. So 6.6261 times 10 to the power of negative 34 joule second times 3 times 10 to the power of 8 meter per second divided by 7.67 times 10 to the power of negative 19 joule. Alright, so you should get your wavelength is equivalent to, because this one is in joule, right? So joule, and then this is joule, and then this is meter per second. This one is second. Therefore, you should get your final answer is equivalent to 2.5917 times 10 to the power of negative 7 meter. But then, if you want to change it to nanometer, this value you just have to times with 10 to the power of 9. Therefore, your wavelength should be equivalent to 259.17 nanometer. So this is the final answer for the first question. Let's move on to question number 2. A 0.24 molar solution was transferred into a cuvette with a path length of 1 cm with an absorbance of 0.075 at 560 nanometer. Determine the concentration of solution if the absorbance is 0.450, given the experiment is being conducted with the same analytical parameters. Alright, so in this question, you were given the concentration and then the path length and also the absorbance along with the wavelength. Therefore, from here, we can use the formula absorbance is equivalent to epsilon Bc. So the absorbance is 0.075 and epsilon is the thing that we want to know, and B is the path length, which is 1 centimeter, and the concentration is 0.24 molar. Therefore, from here, we can have the absorption coefficient is equivalent to 0.075 divided by 0.24. Therefore, your coefficient here should be equivalent to 0.3125. Alright, moving on, in the question, you were asked to find what is the concentration if the absorbance is actually equivalent to 0.50. And then it stated here that the experiment is being conducted with the same analytical parameters. So what we are going to do is we are going to use the same formula. Absorbance is equivalent to epsilon Bc. Therefore, your epsilon you need to find, use the same value that you have calculated just now. and then the absorbance is given to you, so 0.450 is equivalent to 0.3125, and then B, because they are using the same analytical parameters, so your B is actually still 1 centimeter, and now you can find the value of C. So your C is equivalent to 0.450 divided by 0.3125. Therefore, from the calculation, you should get the concentration should be equivalent to 1.44 molar. So this is the final answer for the second question. Moving on to question number 3. A solution was put in a cuvette with a path length of 3 cm. The solution transmitted 30% of the incident light. Calculate the concentration of the solution given that the molar absorptivity is 4000 liter per mole per centimeter. Alright, unlike the previous question, now we are going to use another formula, which is for absorption is equivalent to negative log the incident light at the end divided by the incident light at initial stage. So basically here, negative log, at the end it says that it transmitted 30%. So you can write 30. And then initially it should be 100%, right? Because it's the amount of light that is being transmitted to bombard the sample. Therefore, you should get your absorption is equivalent to 0.5229. Alright, so from this value, we can actually find the concentration of the solution. So absorbance is equivalent to epsilon Bc. So the absorbance is the one that you have just calculated. So we need to plug in this value, 0.5229 is equivalent to the epsilon, which is the molar absorptivity given in the question, which is 4000 liter per mole per centimeter, times the B, the path length, which is 3 centimeter, times the concentration. Alright, so from here we can find the concentration is equivalent to 0.5229 divided by 4000 liter per mole per centimeter times 3 centimeter. So basically here, this one you can slash out. So your concentration will be equivalent to 4.3575 times 10 to the power of negative 5 mole per liter. So this is the final answer for the third question. Alright, now we are at the final question, which is the fourth question. In one experiment, an unknown isomer mixture of a straight chain hydrocarbon without any substituent were analyzed by using the UV visible spectroscopy. The empirical formula for the hydrocarbon was found to be as such, with a molecular weight of 82.0 gram per mole. The UV visible spectrum shows two peaks with lambda max relatively close with each other. Given that the energy of electronic radiation of isomers are 9.256 times 10 to the power of negative 19 and 8.5881 times 10 to the power of negative 19, match the isomer with its lambda maximum. Okay, so the first thing that we need to look at is the empirical formula given in the question is this one, and given to you is the molecular weight, which is 82.0 gram per mole. So from here, we can write the empirical formula to get the N, the value of N. So CH2N CH double bond CH2 2 is equivalent to 82.0 gram per mole. Right, so from here we know that it will be like 14N. So 14 is because of the carbon and hydrogen. So carbon is 12, hydrogen is 1. So 12 plus 1 plus 1. So 12, 13, 14. So 14N plus 54 for this one is equivalent to 82. So 14N is equivalent to 82 minus 54. Therefore, your N is equivalent to 82 minus 54 divided by 14. Therefore, your N is equivalent to 2. Right. Therefore, from here, we can say that the actual hydrocarbon is actually C6H10. Right, so from here we need to find what are the isomer for this molecule. So because we have two peaks, so definitely we have two isomers. Alright, so now let's look at the possibilities of the hydrocarbon chain which reflects C6 and H10. So C6 1, 2, 3, 4, 5, 6. So 6 carbon, because we know that there are two peaks, so there are two isomers. I'm going to just write it like this. Right. So C6 and H10, right? So it means that we need to have double bond. Here, if you can see here, you have two double bond because times 2. So what we can do is that we can put the double bond here, or you can also write the double bond like this. Okay, so from here we know that you have already made two isomers, whereby this one have conjugation and the other one is non-conjugate. Right, so you were asked to match the isomer with its lambda max, but you were not given its lambda max, but instead you were given the energy of electronic radiation. So you have done the first part of the question, but still you need to find what is the lambda max. Right now, so in the question you were given two different energy. Therefore, from this energy, you can actually find what is the lambda max. So what we are going to use is the formula. Energy is equivalent to the Planck constant times the speed of light divided by the lambda, which is the wavelength. So we are going to start with the first one. 8.5881 times 10 to the power of negative 19 is equivalent to 6.626 times 10 to the power of negative 34 joule second times the speed of light 3 times 10 to the power of 8 meter per second divided by your lambda. Therefore, your lambda should be equivalent to 2.3146 times 10 to the power of negative 7 meter. But then we need to convert that into nanometer. You times 10 to the power of 9. Therefore, your lambda max should be equivalent to 232 nanometer. Alright, so up next we are going to do the same thing. So energy is equivalent to the Planck constant times the velocity of light, the speed of light divided by the wavelength. So given to you, the energy is 9.2456 times 10 to the power of negative 19. Therefore, is equivalent to the Planck constant times the speed of light divided by the wavelength. So your wavelength should be equivalent to 2.1499 times 10 to the power of negative 7. So same drill, because this one is in meter, you need to times 10 to the power of 9. Therefore, you will get your wavelength is equivalent to 215 nanometer. Okay, so let's revise back on the isomer that we have predicted just now. We have two different isomers. So 1, 2, 3, 4, 5, 6, and then the other one's 6 as well, whereby they both have double bond. So one is here and the other one is here, and the second isomer we put the double bond just right to each other. So basically, how you are going to assign which one of this isomer have the lambda max of which, right? So basically, this one is the conjugated. The conjugated isomer will have a lower energy. So the one with a lower energy will have higher lambda max. So this one is non-conjugated. The non-conjugated should have higher energy, but in return they will have lower lambda max. So let's compare. So this one is 232 and 215. So therefore here you need to write 215 nanometer, and for the first one is going to be 232 nanometer, because it should have lower energy and higher lambda max. So this is the final answer for the fourth question. So we have come to the end of this week's video. I would like to thank all of you for watching this video from beginning to the end, and I hope this video will help you to understand how to do the numerical question in chapter 3. So I'll see you again next week. Take care and be safe. Goodbye.